Let us sum up the domain and range of all the trigonometric functions that you studied in class 11th. The sine function has the set of real numbers as its domain and the closed interval -1, 1 as the range. The cosine function has the set of real numbers as its domain and the closed interval -1, 1 as the range. Similarly, the domains and ranges of other trigonometric functions, namely tangent, cotangent, secant, and cosecant, are shown here. Let us also recall the concept of the inverse of a function. If a function f from set x to set y, defined by f of x is equal to y, is 1 to 1 and onto, then there exists a unique function g from set y to x such that g of y is equal to x. Such a function g is called the inverse of function f and is denoted by f with superscript -1. Now, using the concepts of the inverse of a function and the domain and range of trigonometric functions, let us find the inverse trigonometric functions. Let us begin with the sine function. As the values of sine 0 and sine pi are equal to 0, it is not a 1, function. On restricting the domain to -pi upon 2 to pi upon 2, the sine function becomes 1, and onto with its range as closed interval -1, 1. In such a situation, the sine function is a bijection, and therefore its inverse exists. Sine inverse of sine of x is equal to sine of sine inverse of x, which is equal to x. Further, even if the domain of the sine function is restricted to the intervals shown here, its range will still remain the same. Now, let us define the inverse of the sine function in the given intervals. The domain of the sine inverse is closed interval -1, 1, and its range is closed interval -pi upon 2 to pi upon 2. The branch with the range -pi upon 2 to pi upon 2 is known as the principal value branch of the sine inverse function. Remember that if y is equal to sine inverse x, then sine y is equal to x. The graph of the sine inverse can be obtained by interchanging the x and y axes in the graph of the sine function. Let's now proceed to the cosine function. As the values of cos 0 and cos 2 pi are equal to 1, it is not a 1, function. On restricting the domain to 0, pi, it becomes 1, and onto with the same range. In such a situation, the cosine function is a bijection and its inverse exists. Further, if the domain of the cosine function is restricted to the intervals shown here, then also the range is closed interval -1, 1. Now we can define the inverse of the cosine function in the given intervals. The domain and the range of the cosine inverse function are closed interval -1, 1 and closed interval 0, pi, respectively. The branch with the range 0 to pi is known as the principal value branch of the cosine inverse function. The graph of the cosine inverse function can be obtained by interchanging the x and y axes in the graph of the cosine function. Similarly, working on the same lines, the other four inverse trigonometric functions can be defined. The domain and range of the inverse cosecant function is shown here. The principal value branch of cosecant inverse is closed interval -pi upon 2, pi upon 2, excluding 0. Here are the graphs of the functions cosecant, and its inverse. The domain and range of the inverse secant function are shown here. The principal value branch of secant inverse is closed interval 0, pi, excluding pi upon 2. Here are the graphs of the functions secant and its inverse. The domain and range of the inverse tangent function are the set of real numbers to open interval minus pi upon 2 to pi upon 2. The principal value branch of tan inverse is an open interval minus pi upon 2, pi upon 2. The graphs of the functions tangent and its inverse are given here. The domain and range of the inverse cotangent function are the set of real numbers and open interval 0, pi, respectively. The principal value branch of the cotangent inverse is an open interval 0, pi. The graph of the functions cotangent and its inverse are given here. The value of an inverse trigonometric function which lies in the range of the principal branch is called its principal value. This table summarizes the principal value branches of all inverse trigonometric functions.